Hi everybody, this is your part 3 of lecture 2, shape of data. Okay, so what we're going to see now is how to study and interpret the shape of the data. Yeah, by just looking at this data, you clearly see that it is a symmetrical data. Yeah, so if this is your median, median is going to be center. Okay, sorry guys, it's not a straight line. The data is symmetrically distributed with respect to the median. Yeah, okay. So how we're going to see how we're going to study and interpret the shape of a data. Okay, so let's go back to the same example for the data containing cholesterol level of 30 adult males. This is just because you're familiar with the data. We have seen how to draw a box and whisker plot for the given data. We have seen how to draw a histogram. Yes. But what do they both say about the shape of the data? Okay. While histogram and box plot both summarize a set of data, they also show the shape of the data, isn't it? They also show us the shape of the data, how the data is spread. Consider this histogram. Yeah, the first one, as we saw in the first slide. Yeah, the equivalent box plot should look like this because it's a symmetrical data, isn't it? Yeah, so the whiskers of the same length. Yeah, so I would say that as you call this as whiskers for box and plot, I would say the best way to say this for histogram is to say it as tail. Yeah, so we have the tail here and the tail here. Yeah, in this case the data is said to be symmetrical. So when you have the shape of the data which looks symmetrical on either side of the median, it's called a symmetrical data. Yeah, the shape of the data is said to be symmetrical. Yeah, because of this, for a symmetrical data, the mean is equal to the median. Yes, let's take the same example which we took in our seminar, okay, last week. 80, 81, 82, 83. So this is the score of 5 students in a class, a max test. Okay, let's take it as a maths test. Yeah, so this is the score of 5 students in a class. So what is the median? 82. What is the mean? 82. For this set of data, the data looks like a symmetrical set of data because the mean and the median are equal, isn't it? So for a symmetrical data, the median is equal to mean. Okay, so now let's see what are the other two shapes. Okay, we have talked about it in the seminar, but not with respect to the shape. Yes, yeah, let's see that now. Before that, I forgot to say this here. So when median is equal to mean for a symmetrical data, Q2 minus Q1 should be equal to Q3 minus Q2. We saw that in an example in box plot in the last part. Yes. So Q2 minus Q1 should be equal to Q3 minus Q1. So for a symmetrical data, median should be equal to mean. Q2 minus Q1 should be equal to Q3 minus Q2. Now let's go to the next shape here. So if data isn't symmetrical, it is said to be skewed. That means the previous shape, the symmetrical shape, is no skew. Okay, there is no skew in that. Yes. So what is the skewed shape? Okay, let's see. So look at that. Look at the tail. The tail is going towards the left. Yeah. So when the tail is longer in the left, look at this, the tail is smaller. Yeah. When the tail is longer to the left, then you call it as negatively skewed. Okay. So the shape of the data is negatively skewed. Look at the whisker, the length, the box plot, how does it look? So this whisker left is longer than the right. Yeah. So in this case, what's happening? The mean is less than median. Take the same example. You have 80, 81, 82, 83. You have the same 5 students. Taking the same seminar example, same 5 students, but now we have a new student coming into the class. Unfortunately, he missed all the lessons and he scored 40. He or she scored 40, okay? He or she scored 40. So what happens to the mean? When you take the mean goes towards the left, isn't it? We calculated the mean goes down, the mean goes towards the left. And the median was still almost close to the old one. So the median was 82 and the new median was 81.5. There was very, very little change with median when compared to mean. Yes, so the mean changed a lot. Mean was around 72, isn't it? So the mean changed a lot, but there was a very little change in the median. So median changed from 82 to 81.5. Yes, that means the median would have moved a little bit here, but the mean would have moved more further. So if the mean is here, I will take it as x bar, okay? If the mean is here and the median is here, Q2, which of this is smaller? The median, the mean should be smaller than the median. So that's why for a negatively skewed data, mean is smaller than median and Q1 minus Q2 or Q2 minus, because Q2 is bigger than Q1 because the number on the right is bigger than the number on the left. Q2 minus Q1 should be greater than Q3 minus Q2. Okay. So that is a negatively skewed data. A data which has got a negatively skewed shape. Okay. What about a positively skewed data? The box plot looks like this. In this case, look at this. The tail is longer towards the right. Okay, so we took this example, yeah, and we decided that we have the same number of students, 5 students first, and then we have a new student coming into the class. But this time the student is super intelligent, very high IQ, okay? He or she comes to the class and he scores 100. And in this case, we saw that the mean tends to move towards the right and the median changes very little from 82 to 82.5. Yes, so the mean moves further towards right, but the median moves very little. So in this case, what happens? The mean is greater than the median because there's very little change in median, but the mean changes a lot, yeah? So it was around 85 or something, isn't it? So this is positively skewed graph, yeah? In this case, mean is greater than median. And obviously Q3 minus Q2 should be greater than Q2 minus Q1. Okay. So we can summarize this as For a symmetrical data, mode is equal to median is equal to mean. For a negatively skewed data, mean is smaller than median. Yeah, mean is smaller than median, while for the positively skewed data, mean is greater than median. Okay, so let me ask you a few questions now before we end this part. Please answer the questions below. Thank you. So we have seen how to study and interpret the shape of data. See you in seminar 1. Thank you, guys.